Hey class, excuse me, this lesson will go with notes from 12.2a. It's an intro to the mean and standard deviation, and we're going to look at how to calculate the mean and standard deviation for a set of data. So a couple notation details and statistics. We use this X with the line on top of it, and we call that X bar to represent mean. We also use mu, it's a Greek symbol, pronounced mu, and those are both going to be used to represent the mean or the average. And then the other new one that we're going to use is S, that stands for sigma. This is the Greek symbol that goes with it. So sigma, and that's going to represent our sample standard deviation. And I'm going to show you how to find those and what they mean. So the mean is the average. And an average that uses the exact value of each entry. So we can say that the average is, this sigma notation, sigma of X, that means the sum of all data points. And then how you find average is then you divide that sum divided by the number of data points. So divided by n. And so we use mu, or you might see X bar. So the sum of all the X's divided by the total number of X's. So then standard deviation, that one's a new term probably for you. It's used to describe the spread of the data about the mean. So the standard deviation tells us how close our data is to our average. If it's the closer the standard deviation is to 0, the closer all the data points are to the average. The larger the standard deviation is, the further away the data points are from the average, basically. Here's the formula that we use. You might see it with the mu or the X bar. But basically, what this says is that you find the difference between all of the X's and the averages, and then you square those differences, divide it by the total number of n's, and then take the square root. So we're going to do one by hand, but these calculations will take a lot of work, especially if you have more than 10 data points. And so it's a lot of work. So we'll use the graphing calculator mostly to find the standard deviation, but I'm going to show you how to do it one time at least by hand. So here's our first example. Find the mean and the standard deviation. So we can use this formula to find the mean, which isn't any different than what you've done before when you found the average. It just looks different. So you find the total sum. That's the sum of x's. And so if you add up all of these, 2 plus 3 plus 3 plus 8 plus 10 plus 10, I got 36. And then you divide by the total number of n. N is 6 here because there are 6 data points. So the average, your mu or your x bar, will be 6. 36 divided by 6. Then to find the standard deviation, I like to keep my work organized in a table because I have to take my x's, so all of my x's here, and then I have to take each x and subtract the average. That's what the inside of the parentheses are. So I have to take each x and subtract the average from it. So 2 minus 6 would be negative 4. 3 minus 6, negative 3. 3 minus 6, negative 3. 8 minus 6 is 2. 10 minus 6 is 4. We have 2 10s. And then I have to square it. So then it's the x minus mu, each of those values squared. So negative 4 squared is 16. Negative 3 squared is 9. Negative 3 squared 9. 2 squared 4. 4 squared 16. 4 squared 16. And then we want the total sum of all of those. So the sum of all of these added together here. So in the last step, we are finding the sum of all of these numbers that we calculated. And that adds up to 70. So then this top part, I got the sum of all of the differences in the mean squared is 70. Divided by n, and remember that n was the total number that we had. So n was 6. And so if you take 70 divided by 6 and then take the square root of that, you should get about 3.42. I rounded that. It's an approximation. So we can say that that is our standard deviation, which we use sigma. So 3.42, which tells me that my average was 6. And the standard deviation tells me that all of my data points are about 3.42 away from the average. About 70% of them are going to be right around the average, 3 away. So the average was 6. So if I put 6 in here, I have 8 and 10, so about 2 and 4 away from the average. And then 3 and 2, which is about 3 and 4 away from the average over here as well. So 70% of my data is about 3 to 4 units away from my average. That's basically what the standard deviation says, how spread out it is. It is a lot of work by hand though. So now I'll show you how to enter this into your calculator. So if you have the TI-84, this will follow the steps. So the first thing is you put it in your list. And I think you have to hit Stat and then hit Edit to edit the list. And put the data points in there. And then you go Stat and you go over to Calculate. So you have to arrow over. And you want to select number 1 there, the one variable statistics. And when you hit enter, it should print out on your home screen this. And then you can see X bar up here. That's going to be your mean or your average. And then sigma of X, that's going to be your sample standard deviation. So you can see that's the 3.42 is our standard deviation. Notice it says n equals 6. That is our how many terms we had. So that's a good way to check that you entered the points in correctly. That you got the right amount of n. So your calculator can do that for you. So you go ahead and try this one. You can pause the video here and give it a try. Note that you have 30 data points. So when you are done entering it, you should have list 1 of 30 should equal the 1.45 or the last point that you put in there. So you should have 30 data points, and when you run it, you should have n equals 30 at the end. So use your calculator. Step 1, enter it in the list. And that's that Stat, Edit. You hit Stat and then you hit Edit. Step 2, hit Stat and then go over to Calculate. And then you want to choose one variable statistics, which is like the first choice there. And then when you hit enter for step 3, you're going to read the X bar as the average. And when I ran it, I got 1.14. And the sigma of X will be your standard deviation. And when I ran that, I got sigma of X to equal 0.81. So it tells me that 0.81 tells me that all my data points are pretty close together within 1 around the average. So plus or minus 0.8 around 1.41 around the average. It's close to 0. And we're going to talk about more with using the standard deviation and how we can use it to analyze our data in the next lesson. Today, I just want you to focus on learning how to find the standard deviation with your calculator. Okay, thanks.